Integration between Xpedition EDM and PLM systems is based on the Enterprise Data Exchange, or EDX, file format. This structured file format allows PLM interfaces to be standardized without concern for the proprietary design data of Mentor and other EDA tool vendors. In this example, we will use the EDX file format to exchange data between Xpedition and Teamcenter. We begin with the design in EDM, specifically the EDM Design Cockpit. The data is stored in the EDM Vault and is checked in and out for editing. To prepare for release to Teamcenter, we need to create the files that are required in the PLM domain. We will start by checking out the schematic to create the parts list, an EDIF of the schematic, and a PDF of the schematic. The bill of materials is a key element of PLM integration. Other files may vary, but all PLM integrations require a bill of materials. Here we create the bill of materials in a specific format expected by the Teamcenter interface. Next, we move on to generating the EDIF of the schematic. The interface uses the EDIF file to create schematic viewing files within Teamcenter. Typically, these files are linked to the assembly object. It should be noted that EDM design output for the schematic PDF, the schematic EDIF, and the part list can all be automatically generated when the schematic is checked into EDM. At this point, we're ready to exit the schematic editor. We will then check the schematic back into EDM. Next, we will check out the layout to create the ODB++ file. The interface uses ODB++ to create layout viewing files within Teamcenter. Of course, additional manufacturing files and drawings may also be loaded into Teamcenter. It should be noted that EDM design output for the ODB++ file, the bill of materials, and a PDF of the PCB can also be automatically generated when the layout is checked into EDM. At this point, we are ready to exit the layout. The layout data is then checked back into EDM. After having checked in the design, we now have a specific folder structure created to store different kinds of files. This is the structure required by the Teamcenter interface. Organizing the project this way allows us to generate an EDX file with the correct structure. Here we see that the schematic and layout derived files have been zipped up and put in specific folders. EDIF and ODB++ files have been moved to their own folders. When the schematic and layout are checked into EDM, configuration rules control where the files are stored. These rules are configured by EDM system administrators to ensure consistency of project organization across all users. Here we see the configuration rules that created the correct project structure for Teamcenter integration. Another EDM system setup is the creation of baseline profiles. Baselines are snapshots of certain project files at a particular point in time. The files to be included in a baseline are controlled by baseline profiles. Files can be defined as mandatory or optional. Here we have created a profile called Teamcenter Release, which includes all of the files that are to be loaded into Teamcenter for product release. With the profile defined and assigned to the project, creating the baseline is done by selecting Create Baseline and selecting the correct profile. We will give it a name that describes the content. The Manage Baseline function provides options to copy, restore the project to a specific state, or to export EDX. Here we will use Export EDX to pass the design data to Teamcenter. Notice that there is a list of objects to be included in the EDX file. If needed, files can be removed on a file-by-file basis. The Teamcenter gateway for EDA is used to load the EDX data into Teamcenter. Simply select the EDX file and perform a Save As. The first time the EDX file is saved to Teamcenter, a new Teamcenter project will be created. The project will have a printed circuit assembly and a printed wire board. The Assign All feature can be used to create new Teamcenter part numbers. In this example, the revision is set to A since this is a new product in Teamcenter. The name can be any descriptive name. Derived items are objects in Teamcenter to which the derived files will be attached. Here we have a drawing item and a manufacturing item related to the top assembly. Again, the assign ID function creates the related Team Center IDs for these items. Derived files are the outputs and drawings created in Xpedition and included in the baseline EDX. Here we are loading drawings, Gerber, and NC drill files. At this point, the data is validated and checked into Team Center. Once the design has been loaded, it appears as a known design for future saves. After the upload of the design is completed, we're able to view the product structure within Team Center. Here we see the base assembly, board objects, manufacturing data, and drawing data. This design does not have any variants. However, if there were variants, the variant assemblies would also have been created. Opening the assembly allows us to view the bill of materials. Notice that the PWB part number has been added to the BOM, even though this was not part of the part list created earlier in Xpedition Designer. Selecting the EDA link displays the viewable files created during the upload to Team Center. The derived files along with the native ECAD data are also displayed as objects in Team Center. Any of the objects can be opened for review. Here we open the drawing item to view the layout PDF. Next, we will return to the top-level product assembly to review the derived manufacturing files. Here we see the drill data and the Gerber data. Again, returning to the top-level product assembly, we can see the rendering data. The schematic rendering file was created from the EDIF file included in the EDX. This is used to view the schematic in the Team Center visualization environment. Here we can easily view any of the components, nets, or sheets contained within the schematic. The PCB rendering file was created from the ODB++ file included in the EDX. This is used to view the PCB layout in the Team Center visualization environment. Again, we can easily review any of the components or nets contained on the PCB layout. At this point, we will split the windows so we can simultaneously view the schematic and the PCB layout. Notice that we can easily cross-probe from the list of components and nets, and the schematic and PCB views both update accordingly. Switching back to the PCB-only view, we can easily measure and mark up as needed. Here we measure the distance from the edge of a component to the edge of a board. We then add a markup note stating that the component is too close to the edge of the board. This note can be reviewed by any member of the design team.